research and innovation in Futuris.
Robotic surgery is already a success story.
Surgical robots are already on the market, and we're already using them to perform operations.
Since the 1st of January, 220,000 patients around the world have so far received surgery with the help of robots. Robots are already real surgical tools. Our task now is to improve them.
This Biorobotics Institute is developing a unique robotic surgery system. It has been dreamt up by European researchers to take over the hands of a surgeon and perform operations.
The robot enters the patient's body via the navel. We firstly insert a small capsule. Then the two robotic arms are inserted through this capsule one by one. Once inside, the robot is configured to be remotely controlled by the surgeon. The robot sends 3D pictures to help the surgeon execute precise, non-invasive surgery on delicate parts of the human body without any visible scar. Single port access surgery, surgery with a single incision, has very few applications today. This technology could help to increase the number of applications, allowing us to perform more complex surgeries on the liver or the pancreas, organs that are too difficult to reach with this kind of surgery at the moment.
Researchers are now making plans to bring the prototype into real operation theatres. But before this can become a reality, there are still a few things which need to be ironed out.
Before the robot can be mass-produced, we first have to think about how to sterilise the motors. We'll also have to do more research on some of its mechanical features so that they can become more reliable and less expensive.
Miniaturizing the robot will demand smaller motors that will use less power. But we need the robot to demonstrate a certain strength for moving inside the human body. Solving this will be a huge challenge.
A robotic surgery system has to be good. It has to meet realistic demands. It has to be reliable and not too expensive. But the technology has also got to be properly maintained so that the patients know they can trust it before going under the knife.
But European researchers are not content with developing robots to help surgeons with operations. They want robots to perform surgery on their own. At this research lab in Verona, scientists think intelligent robots can be taught how to autonomously perform certain medical tasks, like biopsies, incisions, and suturing. This robotic arm is being developed to puncture this model of a human abdomen on its own in search of a tumour in the kidney. Researchers had to translate surgical techniques into numbers that were then transferred into the robot's mechanical and software features.
We talked with surgeons to learn some of their techniques, but it is hard for them to accurately describe forces, speeds, the movements they perform during real surgery. So to solve this problem, we also developed computer simulators to help us get the data we needed.
The simulator helped scientists to input realistic data to the robot to increase its understanding of different surgical scenarios and eventually to become more autonomous.
Simulation helped us to define the requirements of a given surgery, but also to define some particular anatomical features of a kidney tumour. How big is the average tumour? Or what are the normal distances between human organs? We also try to understand the biggest complications a surgeon can face during this kind of surgery and how he might respond to these complications.
Some researchers think surgeons will never disappear from operation theatres, but see robots as a useful tool to increase the accuracy and efficiency of existing techniques.
A surgeon, a human being, is not always able to have the same perception, the same precision that surgical equipment and sensors can have. So an autonomous robot could eventually perform some surgical techniques while at the same time acquiring precise data that could complete what the surgeon can feel and see with his own eyes and hands.
And some surgeons say they are curious to see what autonomous robotic surgery systems could be capable of.
We can see today how a robot is able to perform a biopsy on a tumour inside a human organ. But eventually robots could offer something more when it comes to treatment. They could even try to remove it, or give drugs, or any other substances that could help to get rid of it.
Researchers and surgeons agree that this is no longer the stuff of science fiction. That is why they conclude the evolution of robotic surgery has to be closely monitored.
In the future, robotic surgery will provide tools which are less invasive, that reduce trauma to patients, and will be more and more intelligent.
A robot cannot replace a surgeon. The surgeon must remain in charge of the robot.
Future surgical robots will be able to access human organs through smaller and smaller incisions, or even natural openings in the human body.
Future robotic surgery will look a lot like what writer Isaac Asimov talked of in his book Fantastic Voyage. Some scientists are already doing research on magnetic guidance of tiny robotic capsules inside human vessels. These robotic capsules could eventually reach the most remote regions of our vascular system and could offer treatment. We're not talking about current procedures with scalpels and forceps. If, for example, an illness is present in just a small group of cells, therapy could consist of electrical inputs or magnetic fields or something similar.
After 25 years of research, robotic surgery looks set for a big leap. But will patients be willing to put their lives into the robotic hands of a computer?